we were discussing about the Avogadro's law and the different applications of this Avogadro's law. Like we discussed how this law is helpful for finding out the atomicity of any particular molecule. After that, we also discussed how it is helpful for finding out the molecular formula of a gas. The third use was the relation between molecular weight and vapor density. Also, we use the law to get the relation between the moles, number of molecules, and the volume occupied by the gas at STP. So these were different uses. Now based upon all these uses and the relations, there are some numericals in the textbook. So now we are going to solve today these numericals based upon the number of moles, number of molecules, then how much weight any particular gas it occupies when we say that it is equivalent to 1 mole, and also the relation which directs towards the volume occupied by 1 mole of gas at STP. So let us start solving these numericals. We will be solving first of all the solved ones, so that we will get a clear idea how to relate all these different things. Now, these numericals on page number 80, this is mole concept and Avogadro's number. That is clearly all these numericals are based upon the number of moles, number of particles, means Avogadro's particles, and of course the weight and the molar volume. So let us take the first one. They have asked us in the first step, calculate the number of moles of nitrogen in 7 gram of nitrogen. So the first numerical, we are supposed to calculate number of moles of nitrogen in 7 grams of nitrogen. Now, the given thing is, we have just mentioned n is equal to 40. Now, what is the meaning that n is equal to 40? So, always keep in mind, whichever these numbers they give in front of the symbols of the elements, these stand for what? Their atomic masses. So, these atomic masses are helpful for you to calculate the total molecular mass of the given molecule, whichever they have asked. Now here, which molecule they have asked us? Nitrogen. Now you should know clearly that how nitrogen exists, whether it is monoatomic, diatomic, triatomic. And up till now, we have cleared all these concepts in last year as well as the previous chapter, the chemical bonding, then the types of bonds. So from that, you already know that nitrogen, it exists in which form? Diatomic form. That is, the formula for nitrogen is what? N2. Now, if N2 is its molecular formula, how to calculate the molecular weight of nitrogen? So it's very simple. Molecular weight is nothing but what? Addition of atomic masses or the atomic weights of all the atoms in the molecule. So here, only one atom, which is that nitrogen. That is one type of atom. But how many nitrogens are there? 2. And what is the atomic weight of one nitrogen? 14. So this becomes 2 into 14, which is equal to 28 grams per mole. Fine. So we got the first step. We got the molecular weight of diatomic nitrogen equal to 28 grams per mole. You can also say its gram is understood that it is present per mole. Now, this is the molecular weight. Now, what they have asked us, how many moles of nitrogen will be present in 7 grams? So, for that, we should know how many moles are present in 28 grams. So, how to find out this thing? Now, here, 28 grams is which one? 28 grams is nothing but its molecular weight. Fine. Now, if they say that 28 grams is the molecular weight, always if you remember, the molecular weight of any molecule is equivalent to 1 mole. Means 1 mole of the particular molecule, it is equivalent to how many grams? Its molecular weight. So now, these many grams, they contain how many moles of nitrogen? 1 mole. So, what do we have to find out now? 7 grams will contain how many moles? So, very simple. Just do the cross multiplication. So, 28 grams of nitrogen is equivalent to 1 mole, and therefore 7 grams of nitrogen equivalent to how much? Means just find out 7 into 1 divided by 28. This becomes equal to 7 4s are 28, 1 by 4. That is nothing but 0.25. So, 0.25 is the answer for what? Is the answer for number of moles of nitrogen present in 7 grams of nitrogen. So, very easy. If you look, this numerical is not at all that much lengthy. Within 2 steps, you can get the answer. But the thing is that you should know how to find out the molecular weight, and for that you should know its molecular formula, and after that this main relation you should know that whenever you say a molecular weight, it is always equivalent to how many moles? 1 mole. So that you can easily find out how many moles will be present in any particular weight they will ask. So this clears with the first numerical. Now, let us start with the second one. The first one was based upon the weight and the moles. Now, there can be differences. So, the next one they have asked us is calculate the mass of. We are supposed to calculate mass of 50 centimeter cube. cc and centimeter cube is mind same. 50 centimeter cube of CO. So what is this CO? Carbon monoxide at STP. Fine. So what is this STP? This is standard temperature pressure conditions. And in bracket they have given you some numbers. As I said, these stand for what? The atomic masses of the atoms. Now, I hope you understood the question. What they have asked, calculate the mass of this much. Now, what is this? This is not a mass. This is volume. So, the mass of 50 centimeter cube of carbon monoxide, you are supposed to find out at standard temperature pressure conditions when these atomic masses are given. Now, first step, very easy. Based upon atomic masses, your first job is find out molecular weight of CO. So what is it? CO is this molecular formula. So just go on adding atomic masses of carbon and oxygen. So carbon is how much? 12. Oxygen is how much? 16. So this becomes equal to 28 grams. So what is this 28 grams? This is nothing but the molecular weight of carbon monoxide. molecular weight. With which one now? In the previous numerical, we related the weight with number of moles. But now, here they have not asked you number of moles. So what they have asked you? The mass present in this much amount of volume. So we have to take the help of now standard volume. So what is it? If you remember, 1 mole of any gas occupies 22.4 liters of volume at STP. Fine? So I'll write down here 1 mole of, now which gas is here? CO. Now 1 mole of CO is equivalent to how much? Is always equivalent to its molecular weight. Is equivalent to 28 grams, and which is equivalent to, what did I say just now? How much volume does it occupy? 22.4 liters. But have they asked you this volume in liters? No. So that is in what? Centimeter cube or cc. So we just multiply that 22.4 by which number? 1000, and we'll get it occupies 22400 centimeter cube or cc at STP. Fine? Understood what I said? I first of all found out the molecular weight. I use this relation. 1 mole of CO occupies 28 grams. This is equivalent to 28 grams, which is equivalent to, it occupies how much volume? 22400 centimeter cubes at STP. These values you are supposed to keep in mind. So, now what they have asked us, how much is the mass of 50 centimeter cube of CO? So what is the mass of 22400 centimeter cube of CO? That is 28 grams. So what will be the mass of 50 centimeter cube of CO? So just write down a reverse way. Therefore, 22400 centimeter cube of CO is equivalent to 28 grams at STP. Right? Therefore, the asking is which one? 50 centimeter cube of CO will be equivalent to how much? So just simple cross multiplication, that will be equal to what? 50 into 28 divided by 22400. Fine? We can just cancel out the zeros. Divide this 28 to 24 by the simple number 2, and the final answer which we will get is 0.0625. Now, what is this 0.0625? That is nothing but the mass. So, of course, here the unit will be which one? Grams. So, I hope you understood the complete numerical. They had asked us the mass of this much volume of CO. They had given you the atomic masses. The first step, we calculated molecular weight. After that, we related the molecular weight with mole as well as the volume at ST. Fine? So 22400 cc of CO is equivalent to how many grams? Its molecular weight, which is 28 grams. Therefore, this 50 centimeter cube will occupy how much grams? That will be equal to nothing but what? 0.0625. So this is our final answer. Right? It's very easy numericals. Only you are supposed to keep in mind the relations among moles, number of molecules, molecular weight, and molar volume. Of course, an STP. Now, let us go towards the Next one. So here they had asked us calculate the volume at again same conditions STP which are occupied by. Now here they had given you 6.023 into 10 raised to 22 molecules of gas which is X. This is an unknown gas. They have not given you any particular formula. So no doubt you can easily solve it without having any particular formula. Now here, if you look carefully, then what they had asked us? Volume. Occupied by how many molecules? These many. Now if you look at this one, is this Avogadro's number? No. Why? Because Avogadro's number is how much? 6.023 into 10 raised to 23. Whatever may be the gas. So these molecules are different. This is 10 raised to 22. Now, again, use one more relation. When I am saying 1 mole of any gas is equal to how much? Its molecular weight. So it occupies how much volume at STP? 22.4. Okay, these relations we are looking right now. Now, one more relation we are already done when we studied this Avogadro's law, mole concept and number of molecules. So what is that concept? We discussed that 1 mole or more is the amount of substance which contains number of particles equal to Avogadro's number. So, whenever you are saying 1 mole of any gas, always that amount will become equal to how many particles? 6.023 into 10 raised to 23 at STP. Fine? Now here they had asked what? Volume. So 1 mole always occupies how much volume? 22.4 liter. So what I do now? 1 mole of which is the gas now? X. It doesn't matter whichever is the gas. So 1 mole of gas is equivalent to what? That is equal to 6.023 into 10 raised to 23 molecules. Fine? Now, 1 mole always occupies how much volume? 22.4 liters at STP. Okay? Now, we can relate these two now. So, we'll relate the right hand side. 1 mole is equal to this. 1 mole is also equal to this. So, I can make equal to these two sides. So, 6.023 into 10 raised to 23 molecules of X is equivalent to 22.4 liters at STP. Fine? So what have they asked us now? Calculate the volume occupied by these many particles. So, what is the change in the number of particles? 6.023 into 10 raised to 22 molecules of X will be equivalent to how many liters at STP, which is nothing but your asked volume. So how to solve further? Just do cross multiplication. This will be equivalent to, it is 6.023 into 10 raised to how much? 22 into 22.4 divided by 6.023 into 10 raised to 23. So very easy. These two numbers are same. They will get cancelled. And in the numerator, it will be what now? That will be 22.4. This one power it will get cancelled. This is divided by 10. liters at STP. Fine. So your final answer becomes 2.24 liters at STP. I hope you understood how to solve this one. Whichever molecule they had asked us X. So here there was no question to find out the molecular weight. What we did, we just wrote the relation between one mole of gas will contain how many particles. So we got the answer as what? Avogadro's number. Always 1 mole is equivalent to this 22.4 liters at ST. So we related the two numbers, 6.023 Avogadro's number and this 22.4. And directly we went towards the question, how much volume will be occupied by these many particles? So the answer we got it as 2.24 liters at STP. We can also change it to which one? Centimeter cube if we need it. Just multiply these liters by 1000. So 3 numericals we have done up till now. Now let us go towards the next one. Now here, what they have asked us is, they have given one specific molecule in the next numerical, which is sodium chloride. So sodium chloride, its formula is what? NaCl. So what have they asked? Calculate the number of molecules in 1 kg of NaCl. NaCl they have not given. They have just mentioned sodium chloride. So you should know what is the formula for sodium chloride. Very easy, it is NaCl. Now here, again, in the bracket, they have given you the atomic masses, which are sodium 23 and chlorine 35.5. Now, the thing is, once they give you atomic masses, what is your first job? Before going to the calculation, just make sure about the formula. Once you know the formula, go on adding the atomic masses and find out the final atomic weight. So, molecular weight of NaCl is equal to the addition of atomic masses. So, Na 23 plus chlorine 35.5. That becomes equal to 58.5 grams. Now, whichever this particular molecular weight you have got, this is always in grams. Now, what they have asked you to look at the numerical number of molecules present in 1 kg of NaCl. Means they have asked you the weight. Means the weight they have asked is 1 kg. It is in kilograms. So your job is either to convert this into grams or this weight into kg. Whichever you find it easy for you. So I find this is easy. When you want to convert grams into kilograms, just multiply it by 10 raised to minus 3, or you can also say divided by 10 raised to 3, that is 1000. So, what you are supposed to find out? Number of molecules present in 1 kg. So, I will write down this is equal to 58.5 into 10 raised to minus 3 kg. So, both the weights are now in the same units. So, now, if this is the molecular weight, just use the same concepts which we are discussing up till now. Any particular gas molecular weight, it always contains how many molecules at STP? Avogadro's number. So I can write that 6.023 into 10 raised to 23 molecules equivalent to, or these many molecules presenting 58.10 raised to minus 3 kg. We can also change it in another way. 58.5 into 10 raised to minus 3 kg. This weight is equivalent to, or it contains how many molecules? 6.023 into 10 raised to 23 molecules at STP. Fine. So what are they asked now? How many molecules will be present in 1 kg? So therefore, 1 kg is equivalent to how many molecules? So easy calculation. Just cross multiply 1 into this divided by this. So your answer will be 6.023 into 10 raised to 23, and this is divided by 58.5 into 10 raised to minus 3. So if you solve this particular ratio, you will get the final answer as this will be 17.1 into 6.023 into 10 raised to 23. So this 17.1 is nothing but what? This is the answer for 1 by 58.5. So it's very easy calculation. At least you obtain your answer up to this. Don't leave it up to this previous particular step. Go to the last step and as far as possible find out the simplest answer for any particular question they ask you in the interview. So very easy. Here what we did, first of all, whichever molecule they had asked, we found out its formula, molecular formula. We added the atomic masses, found out the molecular mass. That molecular mass always contains number of particles equal to what? Avogadro's number at STP, and we got the final answer. So remaining numericals and the next concept we will see in the next lecture.